Hi guys, welcome to You Can Do Math. Today we are talking about sequences and we are in section 521, and today by the end of the lesson you should be able to recognize if a sequence is geometric, if it's arithmetic, or maybe it's neither. Let's go ahead and start with our opener problem, which is I would like you to simplify using the property of exponents. So if we take a look, if you notice, we have two terms that are multiplying each other. And so I'm going to take a look at these big numbers out front and we can multiply them. 4 times 2 is going to give us an 8. Now let's take a look at the x's. I notice, and I'm going to switch colors here, that I have this x to the third power and this x to the negative third power. Well, because I have the same base, I can simply add the exponents. And 3 plus a negative 3 is x to the 0. Now anything to the 0 power is 1. So it's like saying 8 times 1 if we were to put it after this 8 right here. So therefore we can just say it's just 8 right there. And the x to the 0 will just kind of cancel. Next is we are left with, and I'm going to switch my color again to the y to the negative 1 power. There are no more y's, and so now I need to look at that y and decide I need to leave my answer in all positive exponents. Therefore, I'm going to draw a fraction, and when I bring it down to the denominator, it now becomes positive. And this is your final answer, 8 over y. So the first power, or you could just write 8 over y. All right, so let's take a look at this sequence, this list of numbers, and it is growing by a certain number every single time. What is it? 2, 6, 18, 54. Maybe multiplying by 3? And if that's your guess, and if that's the case, it needs to work for every single time. So is 6 times 3 18? Yep. Is 18 times 3 54? Yep. Is this sequence linear? No. Remember, linear is going to be adding or subtracting by the same number. We are now multiplying. In previous lessons, we've talked about how this would be an exponential growth. But with sequence, it is a little bit different. There are two types of sequences. There is arithmetic and there is geometric. Now, arithmetic means we're adding a constant to each of the previous term. And then if the sequence is geometric, that means that it's multiplying by a constant, by a same number every single time. Now, if this video goes too fast and you weren't able to write this all down, please pause this video and write this section down. And I'm moving forward to the last slide today, kind of short notes. Can you take a look at these 4 and determine, is it arithmetic or geometric? How are these sequences growing? Let's take a look at the first one. So -4 to -1, -1 to 2, and 2 to 5 looks like we're adding 3 each time. So if we are adding 3 each time, this means that this sequence is arithmetic. All right, let's take a look at the second one. I'm going over to the right. We have 1.5 to 3. 3 to 6, 6 to 12, looks like we're multiplying by 2. And we're multiplying by 2 each time, and therefore this is geometric because we're multiplying. Let's take a look at the third example. The third example is pretty special. It's actually neither, right? If we're moving from 0 to 1, that's adding 1. But then we're not adding 1 to get to the 4 and then it continues on. Now this one is special because there's still a rule that's happening. Take a look at this. If I have 0 squared, I have 0. What about 1 squared? 1. And then could you guess the next one? How about 2 squared? 4. And 3 squared? 9. You guessed it. This is quadratic. But for right now, for our sequences, we're going to call this neither. It's not arithmetic and it's not geometric. Okay, last one's for you to try. Let's see how you do. So pause this video, try to figure it out. All right, how'd you do? Adding 1.5 each time? You would be correct. And so that means that this sequence is arithmetic and its constant is adding by 1.5 each time. All right, guys, I hope that you enjoyed today's lesson, and I'll see you next time. Bye.